Assalamualaikum and good afternoon to one and all. Today we'll study about anti-convulsant activity by using convulsometer. I am Professor Sheikh Abu Sufyan. Welcome you to AS Academy Learning Forever. At the end of this e-learning session, you are able to learn aim and objective of this experiment, discuss different methods and principle of studying anticonvulsant activity, and lastly, based on given data, analyze and interpret the result of this experiment. Let's start with aim and objective of this experiment. So the aim and objective of this experiment is to study anticonvulsant activity by using convulsiometer. So the activity we are studying, it is anticonvulsant activity, and the instrument we use to evaluate this activity, it is convulsiometer. It is also called as electro-convulsometer. Let's see what is the requirement of this bioassay. So to perform this bioassay, we need either rat or mice. So animal that we select, it is either rat or mice. Apparatus we are using, it is electro-convulsometer, and drug we are evaluating, it is anticonvulsant drug. So any anticonvulsant drug which can reduce tonic-clonic convulsion or grand mal convulsion can be evaluated by using electro-convulsometer. Let's see the important terms, mechanism and type of convulsion before going into the detail about the principle and procedure of anticonvulsant activity. So first important term that we must know, it is what is convulsion. So the convulsion, basically it is sudden violent movement of body that you cannot control. So the convulsion, basically it is the sudden movement. So suddenly you are standing or maybe you are sitting and suddenly you suffer from the violent movement, isn't it? So what is the nature? So the nature of this movement, it is the violent. So you are suffering from the violent movement of your body, and this movement that you cannot control. For example, if you want to move the hand, then the movement of the hand you can easily control. But if during the convulsion, if the movement of the hand and your feet it is started, then those movement cannot be controlled. So if this is the case or this is the manifestation of the patient, it means the patient is suffering from the convulsion. Now let's see quickly about what is the mechanism behind the convulsion and what is happen at the molecular level that is responsible for this manifestation of the convulsion. So we have studied the detailed mechanism in the chapter of anticonvulsant drug in the theory, but today I will just summarize what we have studied. So first important thing that you must remember is the convulsion, it is a result of excessive excitement of your central nervous system. Okay, so there is excessive stimulation of central nervous system, it is responsible for the convulsion. Okay, so excessive stimulation of the central nervous system, and if you try to relate it with different with specific part of the brain, then the part of the brain involved or part of the brain involved, it is basically the corticular neuron. Okay, so the which part of brain is involved? So part of the brain involved, it is corticular neuron. So the corticular neuron, so in this portion there is excessive CNS stimulation, or it is also called as hypersynchronous discharge of population of corticular neuron. Okay, so either there is excessive stimulation of central nervous system, or you characterized at mechanical level at molecular level this condition as, I am writing here, it is hypersynchronous. Please excuse me for the writing, it is hypersynchronous discharge of, so discharge from neuron means what it discharge? So it discharges the impulses. Okay, so if there is this impulse discharge, if it is increased, so if the excitement of the, if there is excessive excitement is there, right? Or if there is excessive discharge of the neuronal firing, that is called as hypersynchronous, and this is also the synchronous in nature, means continuously there is excessive discharge. It is occur in case of the cortical neuron, then in those case or in that patient will suffer from the convulsion. Okay, so this is basic the mechanism of the convulsion. So to summarize, the convulsion, it is result of excessive stimulation of central nervous system. Specifically, it is due to hypersynchronous discharge of cortical neuron. So what you need to do is, in order to control the convulsion, you need to reduce excitement of the CNS, or you need to reduce hypersynchronous discharge. So instead of hypersynchronous, it must be the synchronous discharge, isn't it? Not an excessive discharge. It must be the synchronous discharge of cortical neuron. So there are many category of the drug which can be used for for controlling this excessive stimulation of the CNS or hypersynchronous discharge from the cortical neuron. So first we'll see what are the different types of the convulsion before going into the actual experiment. So there are basically the two important types of the convulsion, although there is one more category is there, but there are two important types of the convulsion. The first type of the convulsion, it is called as tonic-clonic convulsion. Okay, so it is called as tonic-clonic convulsion. This convulsion, it is also called as grand mal epilepsy. So if patient is suffering from this type of convulsion, it is also called as grand mal epilepsy. Okay, so this tonic-clonic convulsion, or it is also called as grand mal epilepsy, or it is also called as major epilepsy. So this is characterized by sudden loss of consciousness. So first important symptom which is seen in the patient, it is loss of consciousness, followed by generalized tonic and clonic convulsive movement. So you can see the characteristic movement of the muscles in that patient. So it is of two types. One, it is the tonic, and second one, it is the clonic convulsive movement. And this is followed by the headache, drowsiness, confusion, right? And patient also sometimes show the frothing, that is excessively salivary secretion from the mouth, and he also show the symptom of micturition and defecation. So these are the symptom of tonic-clonic convulsion, that is the also called as the grand mal, or it is also called as the major type of the epilepsy. Okay, so this is the first type of the epilepsy. And second type of epilepsy, it is also called as petit mal convulsion. Okay, so the second convulsion, it is called as petit mal convulsion. So just I am quickly writing that type of convulsion here. It is called as petit mal, or it is also called as absence seizure. Okay, so what was happen in case of the first convulsion? There is complete loss of consciousness. But in case of petit mal convulsion, there is no loss of consciousness. Okay, and it is characterized by sudden cessation of ongoing conscious activity. Now, what could be the ongoing conscious activity? Suppose you are speaking along with your friend and you suddenly stop in between. Okay, or in mid sentence you stop. If you are walking and suddenly you stop, right? So the conscious activity, it is the speaking, right? If you stop in between, so this indicate that the patient may be suffer from absence seizure, and that is not under his control. Now suppose willingly sometime you stop while speaking. So when you stop while speaking, and that is based on your willingness, then that is not called as absence seizure, isn't it? So unwillingly, if you stop in between the sentence, you don't want to stop, but suddenly you stop, which is not under your control, then this is a very important indication of absence seizure, or it is called as petit mal convulsion. Another important characteristic is that there is no convulsive movement. Like in case of tonic-clonic convulsion, you see the synchronous movement of all body muscle, but this is not seen in case of the absence seizure, and also there is no loss of postural control. Whereas in case of tonic-clonic convulsion, patient will fall down, he become unconscious. Whereas in petit mal or absence seizure, sometimes he may be standing and he is just showing the symptom of the petit mal convulsion or absence seizure, but he may not lost the postural control, isn't it? So these are two important types of the convulsion, and we can use the medicine for the treatment of these different types of convulsion. Now, when you are using the medicine for the treatment of this convulsion, now suppose if you want to evaluate the activity of those drugs in animal model, because before going into the clinical study, any drug must be evaluated at the preclinical level. So you need to study their activity at the animal model level. So if you want to evaluate their activity at animal model, then there must be some model which can represent tonic-clonic convulsion, and there must be another model which can represent petit mal convulsion. So you can do anything to the animal where that your process must produce the tonic-clonic convulsion, so that you can give the drug and see whether your drug it is effective in tonic-clonic convulsion or it is effective against petit mal convulsion. Now let's see how it is possible. So there are different methods of studying this anti-convulsant activity. So please excuse me. So there is, I could not change this title. So let's quickly, I will change the title. Yes. So there are different methods of studying anti-convulsant activity. Let's see what are those methods. So the first method, it is also called as maximum electroshock method. It is also called as the MES. So when you induce convulsion by using maximum electroshock, where you are giving electrical current. So when you apply or when you give the electrical current to the brain, what will happen? It will increases the excitement of the brain. It will produces what will say the hyper synchronous discharge from the cortical region. So you can apply your electrode at the area of the brain or area or part of the body which can produce a hyper synchronous discharge of the cortical neuron, isn't it? So that is called as the maximum electroshock method. So what you are doing, you are giving the electrical current to the extent where animals show the convulsion or animals show the symptom of the seizures. Okay. So if any drug which is active against maximum electroshock induced convulsion, then it means that drug it is effective in for the treatment of grand mal epilepsy. Why? Because maximum electroshock method, it represents grand mal epilepsy, means it produces the symptoms or the changes at the molecular level which are similar to the tonic-clonic convulsion or the grand mal epilepsy. So MES convulsion, it represents grand mal epilepsy, and any drug which can reduces the MES induced convulsion, it is having the ability to reduce grand mal epilepsy. Okay. Second model, it is so before going ahead, let's see how we can induce the MES convulsion. So we can use two type of electrode. One, it is the corneal electrode. So corneal electrodes can be applied at the cornea. So you can apply those electrode at the cornea of that mice. So when you apply this electrode and give electrical current, that animal will suffer from the convulsion. So one, it is the corneal electrode, and second one, it is by using the ear clip. So we'll see the ear clip because in our college we have the ear clip. So I will show you that in an image. So you can apply the clip on the ear pinna and then you can give the shock. So it can carry that electrical shock to the cortical region of the brain, and it may lead to their excessive firing, right? So these two methods we can use in order to induce convulsion by using MES. So corneal electrode, and second one it is by using the ear clip. Second method, it is the chemoconvulsion. So name itself indicate that what you did in case of chemoconvulsion, you have used the chemical to induce the convulsion. So you can use the different chemicals. So mostly for the animal model, well-known chemical, it is the PTZ, that is also called as pentylene tetrazole. Even you can use the strychnine to induce the convulsion. So that is called as the strychnine induced convulsion. Okay. So all this model, since how it is induced? It is induced after giving the chemicals. So it is called as the chemical convulsion. And all this model which produces the convulsion through the chemical, it represents petit mal convulsion, or it is also called as the absence seizure. Okay. So if your drug, if it is effective against chemical induced convulsion, that indicate that the drug it show activity against absent seizure. Now if your drug it is effective against both, that is maximum electroshock induced convulsion and chemoconvulsion, it means your test drug it is effective against both type of convulsion. So we have seen there are some drug which having the activity against both the type of convulsion, including tonic-clonic convulsion as well as in case of the petit mal convulsion. Okay, if the drug it is only effective against maximum electroshock, it is not effective against chemoconvulsion, it means that drug can be used only for the treatment of grand mal epilepsy. So this is how you can evaluate the different drug with different activity or in the convulsion or the activity against different types of the convulsion. Now let's see about the principle of this experiment. So what you are doing, first you induce the convulsion by applying the electrode at specific portion, like maybe you can apply the electrode on the cornea or you can apply the electrode on the ear pinna, right? And once you apply the electrode and give electrical shock, what will happen? Animal will fall down and he will start showing the different symptom of the convulsion. So in this process, animal undergo the 5 phases of the convulsion. Now we need to measure how much time spent by the animal in each phase of the convulsion. So we measure the time specifically in the second. So there are total the 5 phases. So first phase it is the tonic flexion. Now what happens when animal it is present on upright position? So upright position means he is standing on his legs, right? Both hind paw and forepaw. So he is standing on his legs, and then what you did, you have applied the electrode. The moment you switch on and you have given the electrical shock, animal will fall down, because first symptom of tonic-clonic convulsion it is unconsciousness, and due to unconsciousness animal will fall down, right? And he will show different phase. Now first phase it is the tonic flexion. Now what is tonic flexion? So basically the flexion it is the moment that decreases the angle between two body part. Now suppose, now this is the animal when it is fall down, right? And this is the back of the animal. Okay. So when this is, and this is the front paw and these are the back paw. When these two paw, when they come closer to each other, so what will happen due to this paw coming closer to each other? It means if this is the normal body angle, and if when these two paw are coming together, what will happen? The body will bend something like this. So animal body will bend something like this, and due to that there is decrease in the angle, right? So the flexion it is the moment that decreases the angle between two body part. So here you can see there is decrease in the angle of between two body part. So basically what is happening, the moment animal fall down, the animal both front paw and back paw will come closer. So when it come closer, and the time for which it's coming close, that is called as the tonic flexion phase. So you need to use the stopwatch to measure the time spent by the animal in that particular phase, or you can do the video recording and later on you can measure the time. Anyway, any method you can follow. So first it is the tonic flexion. So what is happening in case of the tonic flexion? So just quickly write, there is a decrease in angle. So angle it is decreased. Why? Because both front paw and the back paw of the animal, they are coming closer, right? Second phase, it is the tonic extension phase. In tonic extension phase, so it is followed by tonic flexion. So first there is flexion, then there is tonic extension. So name itself indicate that in tonic extension phase, what happens? Due to the movement, there is increase in angle of the body. What it means, the animal both hind paw or both the front paw and back paw, they are stretched. So they are extended. So first in first phase, that is tonic flexion, they will come together, whereas in second phase they are extended, means they are going away from each other, and as a result of that this angle will increase. So this angle it is increased. Why? Because this is, suppose if this is the front paw, then front paw going back, or they are extended, and suppose this is the back paw of the animal, so both paw of the animal or both the legs of the animal they are going away from each other, and as a result of that there is increase in angle. So it is called as tonic extension phase. So generally animals spend more time in tonic extension phase of the convulsion. Okay, so you will be measuring again this time, how much animal has spent time in the tonic extension phase. Third one, it is clonic convulsion. So after this phase, that is the third phase, that is after second phase, that is tonic extension. Once extension phase is over, right? So animal stretch his both the paw. After that, the animal starts showing some synchronous movement. So his both the entire body, it is shaking and it is moving, isn't it? So that phase, it is called as the clonic convulsion. So it is the synchronous movement of entire body or entire musculature of animal, it is seen. So that is called as the clonic convulsion. So you see how much animals spend time in the clonic convulsion. And fourth phase, it is called as the depression or the stupor. So it is the intermediate phase between clonic convulsion and the recovery. So before recovery, animal it remains in depressed phase, means his eyes are open, you feel that animal has recovered but still not start walking, isn't it? So the time for which the animal remains in depressed phase, where it is not completely recovered, that is called as the depression phase, or that is called as the stupor phase. So again you will measure the time the animal spent in this phase. And lastly, the recovery, where animal standing again on his forepaw. So we have started, or the convulsion start with the symptom where animal fall down. First show the tonic flexion, where both front paw and back paw come together or come closer to each other, and there's decrease in the body angle. Then second one, it is the stretching of both front and back paw, which lead to increase in the body angle, right? Third one, it is clonic convulsion. So clonic convulsion is characterized by synchronized movement of the whole musculature of the body. Fourth, it is depression or the stupor phase. So it is the intermediate phase between clonic convulsion and the recovery, where animal remains in depressed phase. Means he is not completely recovered. He is still unconscious. Okay, although he is partially recovered but still not conscious. Okay, if you tap the table or if you try to pinch that animal will not show the response, right? So that indicates the stupor phase. And lastly, the recovery, where animal is completely alert and stand on his forepaw. Okay, so these are 5 phases are shown when you give electrical current by using the ear pinna electrode or by using the corneal electrode in case of the animal. So this is the principle of the anticonvulsant activity by using maximum electroshock method. Now let's see about the instrument. So how its work and their working principle. So this instrument, it is called as electro-convulsometer, and this electrode that you see, so it is simply the clip, right, which is connected to the wire, and this wire or this electrical connection, it is connected to electro-convulsometer. Okay, so basically this is the apparatus which provide the specific current to the animal. Now if you see the control panel, so what is there? This is plus, increase and decrease is there. So on the base, by using this key, you can set the time for how much amount of time you want to give current to the animal, right? So you can set, for example, most of the time we give current just for 2 seconds or just for 3 seconds. It's depend on your protocol, but mostly we use the 2-second current for the animal, right? Then we can use this different key to switch on this instrument. So this is the key to switch on the instrument, right? This is the main key, right? So main key you can start so that electrical current can be supplied, and then you can adjust desired current, how much voltage of the current is required. Especially we use the 150 milliampere, right? So we are using 150 milliampere of the current. So once you set by using these different current, like for example, if you want to give the 150, now suppose how you will give the 150. So this is the stimulus current, so you need to set to the 15, right? Then you can set the multiplier, because 150 milliampere is required, so you can set this multiplier. So that is 15 multiplied by 10 become a 150. So you can set this to the 10, right? So when you set to the 10, right, and this key at the 15, it will provide current to 150 milliampere. Likewise, you can use this key also to set the different reading. Like you can set the reading at the A or B, maybe the milliampere you can select, or you can select the reading at the ampere. So you can make use of all those key of the control panel to select the desired current and desired the time for which you are going to give the current. So moment you apply this electrical what we'll say this the ear pinna electrode on the animal ear pinna, right? What you can do next, you can switch on this, right? The moment you switch on, it will show the current, it will blink this light, right? And this light remain only for the 2 seconds. So although the ear pinna electrode are there, but if the light it is switch off, that indicate that the current it is over. Now no more current you are giving, because if you give current for more time, that animal will die, that animal will not show the symptom of the convulsion, right? So this is the basically the instrument that we are using. So point to be remember, what is the name of the instrument? Electro-convulsometer, right? And what type of convulsion what type of electrode you are using? You are using the ear pinna electrode, right? You are using, or you can also use the corneal electrode. So only difference is that instead of this pin, there is just another electrode which having the shape of your the cornea, that simply you can apply on the cornea and then you can start the current. Let's see about the procedure. So in the procedure, there are few important parts are there. First important part, it is the selection of the animal. How you select the animal? So what you are going to do, you can select the mice of either sex, maybe weighing about 25 to 30 gram for the experiment. And then 1 day before the testing, so this is very important, 1 day before the testing, the animal are given with electrical shock of 150 milliampere for 0.2 second. So we are giving the shock that we supposed to give at on the day of the trial. So you are giving that just 1 day before, right? And when you give this shock, what it will do, the animal will produce extension of hind limb. So we have seen different phase of the convulsion. Out of this extension phase, it is very important, that must be produced by the animal. So if it produce extension of the hind limb, then only those animal which produce positive result are selected. It means animal, if when it is given with the current of 150 milliampere for 0.2 second, and when it produces the extension of the hind limb, only those animals should be selected. If some animal, if they are not able to produce the extension of hind limb, then you should not select those animals. So this is the selection of the animal. The number of the group, so for the study you are using 2 groups of 5 animal each. So first group, it is the control or the vehicle, where you are going to give only vehicle to the animal, no drug, right? And second group, it is the treatment group, where you are going to give the treatment to the animal. So number of group are the 2. The electrical shock you are giving 150 milliampere for 0.2 second, you must remember this. Then application of the electrical shock, it is generally done 2 hours after the treatment. So in case of vehicle treated group, no problem, because there you are going just giving the vehicle. But as far as possible, you keep same protocol. Means 2 hours before or 2 hours after treatment with the vehicle, first you apply electrical shock, and then again in next group or second group you are giving the treatment. Means you are giving the phenytoin as a medicine, and then after 2 hours of that you are giving the electrical shock, and then you measure how much amount of time the animal spent in each phase. Okay, so that is called as observation of phase of convulsion. So each phase it is measured specifically in the second. So this is all about the procedure of study of anti-convulsant activity by using maximum electroshock method. So now I am going to the Excel sheet where you can realize that how we can interpret the result. Okay, so I already shared these on your Google Classroom. So I'm going directly to the classroom. Okay. Yes, so in today's experiment, what I did is you need to there is no need to calculate the dose to be administered, because from last all experiment I have already shown you demo for calculation of the dose. So I am not asking you to calculate the dose because you are already well versed with that process, right? Now in today's experiment you have to just calculate mean time spent by the animal in each phase of the convulsion, and then you can draw the bar graph to interpret the pharmacological activity of given drug as discussed during lab session. So this demo of bar graph also I am not going to give, because I have already demonstrated this in last 2 experiment. Okay, now let's see how to interpret the result. So that is very important part. and that is something which is different from other experiment. Yes. So let's it get open in the Google Sheet. Yes. So it is open. So now what was the procedure? First we have selected the two group. Then before giving the electrical shock, so 2 hours before giving electrical shock, the control group was given with the vehicle. So it is vehicle treatment group. So control group, you have not given the drug, you have only given the vehicle. Whereas in treatment group, what you did, you have given the drug, right? So you can give anticonvulsant drugs. It is maximum electroshock method. You can use the drug which can be effective in this type of convulsion. So you can use the phenytoin, okay? So you can give the phenytoin, so 2 hours before the electrical shock. And once you give that, after 2 hours, you can give the electrical shock and you can measure the time spent by animal in different phase of the convulsion. So let's see the reading or in case of the control group. So if you see the reading of the control group, in case of the flexion, you can see the on an average, let's calculate the mean so you can get the idea. Sorry, I think it is not taking the mean. I think it may take the average. Yes. So how much average is coming? It is almost 3. In this case, just I can stretch it. It will show us average of all the reading, right? So this is the flexion phase. So animal spent 3 seconds in flexion space. Extension phase, animal spent 10.2 seconds. Clonus phase, animal spent 3 seconds again. Stupor phase, animal has spent 121 seconds. And when we study the recovery and death, it is observed that in control group, out of 5 animals, 3 animals are recovered and 2 animals there is no recovery and they die due to electrical shock. Okay, so there is recovery of 3 animals and 2 animals are not recovered. So this is in case of the control group. Whereas in case of treatment group, now when you see the reading for the treatment group, just first calculate what is the average reading. Now you can see it is coming to 2. So flexion phase, it is decrease, right? Extension phase, it is coming 2.6. Clonus phase coming to 3, there is no much change, and stupor phase coming to 101, it is little bit decrease. Whereas in case of observation of recovery and death, it is observed that all animals are recovered. There is no death in any of the animal, right? So now if you compare, just I will, yes. So if you compare these two table, now you let me know out of these two table, which phase it is significantly affected. So if you compare these two table, you can see this phase, that is tonic extension phase, right? It is significantly reduced by the treatment with the phenytoin. So you must remember that animal, after the inducing the convulsion, if it can reduce tonic extension phase of the convulsion, I will give you the nice color so you can easily remember that. So if it can reduce the tonic extension phase after the treatment, that indicate anticonvulsant activity of the drug, isn't it? Now suppose if you have given the treatment, if you have given the test drug, something which is other than phenytoin, right? And you observe that there is no change in extension phase. The extension phase, the reading, that is mean reading, it is almost same as in case of both control as well as phenytoin, the reading it is same. That indicate that the drug does not having the activity against grand mal epilepsy or maximum electroshock induced epilepsy, right? So this is how you can conclude. So how you will conclude? So tonic extension phase, in case of the phenytoin treatment group, it is significantly decreased. So it is significantly decreased as compared to tonic extension phase of the vehicle control group. So this indicate anticonvulsant activity of the phenytoin. So this is how you can write the interpretation. So I have done with my experiment. If you like my session, then do remember to give me a thumbs up. Okay. Now for a quick discussion, I request all of you to quickly join the Google Meet, so that if any doubt is there, I can resolve. We can have the quick quiz, and then you can go for the calculation and interpretation of the result part. Okay, so quickly join the Google class.